Hey everyone, so we're going to go over the Unit 5 test review. It is a good thing to have your calculator up. And if you don't know how, clear your calculator's memory. Sometimes when someone's been messing with it, or if you've been doing other questions, you could mess up some of your calculator's functions. So to clear the memory, you hit the second button, the plus button, and then 7, 1, 2. And it's all cleared and ready to go. And just in case you want to know that again, it's the second plus 7, 1, 2. Okay. So question number 1 in the review is Marty purchases cashews. The relationship between the cost and the number of pounds that he purchased is modeled by the graph. When we're looking at this graph here, it says that we are looking at cashews. Do they cost 19 per pound, 2 per pound, $9.50 per pound, or $28.50 per pound? When I see those information per pound, that means that my pound number needs to be equal to 1. And when I'm looking at my graph, I don't see a 1. Here's the pounds. I don't see a 1 on my graph. But what I do see is a 2, and I know this is 0. Well, there's a line between 2 and 0. And so that line between 2 and 0, I know that that is the number 1. So if I'm looking for per pound, I'm looking for 1. I can take that 1 and I can go up and trace it over. And at 1, I have $9.50, and that's dollars. So it's $9.50 per 1 pound. And that is question number C. Okay. Problem 2. Which graph models a relationship with the same unit rate as the situation described? So again, we've got these different situations at the bottom, and I want to figure out which one is represented. Do we have 4 and 6? So I'm going to start with the green. I'm going to look at 4 hours baking and 6 cakes. So if I go up to 4, it's nowhere near 6. Okay. So let me try 3 for $13.50. So 3 goes up. Well, 3 goes up to 18. That's a 1/8. Okay. I don't think that's right. Before I go any further, I am going to split these up. So if this number here is 9, and I know that this here is 0, that means 1, 2, 3. Each one of these is going to be 3. So we've got this number should be the number 3, and this right here should be the number 6. So we're counting in intervals of 3. That might help me. Okay. 3 pounds of coffee for $18. So if I'm at 3, oh wait, I said this up here. Let me erase what I had. This right here is 18. So 3 at 18, that is what I have here. So that's going to be letter D. Okay, let's look at these others. We already know 3 for 18 was the letter D, so that means I have 3 other options for these two. I'm going to look at this graph on the right because it seems to be a little bit easier to read. So whatever it is at 1, I'm looking at for every 4 of something, I've got 1 other. None of those are unit rates. None of these are per 1 each and every. So what I'm going to do is I'm going to take this information and I'm going to divide it. So I'm going to take I want to figure out for each hour. So I'm going to take 6 cakes. And I'm going to use my calculator, and I'm going to do 6 divided by 4. And 6 divided by 4 gives me the number 1.5. So that's my per rate. And then I'm going to take the number 1350 and divide it by 3. So 13.5 divided by 3 equals 4.5. So this one's 4.5. I guess I'll put over here 1.5. And then this last one, I've got 288, so 2.88. I'm going to divide that by a dozen. Well, what is a dozen? Well, a dozen means 12, so I'm going to divide 288 by 12. And that gives me the number 0.24. Okay, so 1 and 4. I don't see where 1 and 4 is. Do you? Let's come back to it. So what about this one? Looks kind of promising here with my 288. So for every 1, this over here is 0.24. So let's look at something that's easy to read. Okay. I don't exactly know on this graph on B what each one is. So I'm going to take, and I want to find something that's easy to read. So this 1.2, if I go across and 5, well, I can take that 1.2 and divide it by my 5 and see if I have any of these answers. So 1.2 divided by 5, and that's going to give me 0.24. So B goes here. So I need to figure out where this 4 and 1 comes from. So I took 1350 and divided by 3, and I got 4.5. So stop it. 4.5, that's not up there. Okay. I also don't have, I wonder if I took, and instead of doing that, what if I did 4 divided by 6? 4 divided by 6 gives me 2/3. It's not it either. I may have to come back because I think Miss Harrell made a mistake. So we'll come back to this in a little bit. Okay. So now we're going to go on to proportional and non-proportional. To figure out if a graph is, or if this information is proportional or not proportional, I want to know what is my y-intercept, and the variable that covers our y-intercept is b. So I'm looking at the equation y is equal to mx plus b. Okay, and this b is the important part. Now, if b is equal to 0, then it is proportional. If b is anything other than 0, it's not proportional. Okay, that means when our input is x, when our x is 0 and our y is 0, it's proportional. If our x is anything else, or if our y is anything else, it's non-proportional. So I'm going to come back to the tables in a second, and I am going to look at my equation. Here I have, and here I have. So if b is equal to 0, well, right here I see that b is equal to 4. That means that one is going to be not proportional because there's something after this x. There's something after the x, it means it's not proportional. But there's nothing after this one. If I replace this b with the letter or a number 0, is that going to change that equation? No, it's not. So it means that this is proportional. Now, proportional also means that the y-intercept has to go exactly through the origin. It needs to have x and y is 0, 0. Does this y-intercept, does it cross the y-axis at 0, 0? No, it doesn't. It crosses it somewhere. It's some negative something. So this one is non-proportional. Which leaves me with my tables. My tables, none of my x's have a 0. So I'm going to have to put these into my calculator and use stat edit to figure out which one, let me go back, which one's proportional or not proportional, or if they're both proportional or not proportional. So you hit the button stat, and we're on edit, so I'm going to go ahead and hit enter. And I'm only going to enter 2 numbers. My x's are L1s and my y's are L2. So I do have to enter it in different. It's -25 and -10. Then I'm going to move over to enter my y's that correspond with those x's, which is -20 and -8. So I have 25. Ooh, I did that backwards. So 25, I entered it as I saw it. And that was going to give me the wrong answer. 25 and 20 are my x's. So -25 and -10 go correct. My 2 ordered pairs are together. And -20, there we go. So now that I've got my x's in L1 and my y's in L2, I'm going to hit stat again, scoot over to calc, go down to 4. I need this calculate to be highlighted, and I hit enter. And I've got my A is equal to 0.4. My B is equal to 0. Well, if B is 0, then it is proportional. Yay. So I have this other table I need to do. I go back to stat edit, and I hit enter. And my okay, I need to hit 3. My next one is 4. And you can enter in more points if you want, but you only have to enter in 2. And I'm entering these 2. And -7 and -9. So I have 3 and -7, 4, -9. Go back to stat, go over to calculate. And I'm going down to 4 because I want it to give it to me in this slope intercept form. Oops. Stat, calculate, 4. I hit enter, 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 enter. And now my A is equal to -2 and my B is equal to -1. Well, my B is not equal to 0, so this is non-proportional. Okay. Now, on to the functions, which is not y as a function of x. It's just a fancy way of saying, does it work? Is it linear? When we're looking at functions, x cannot repeat. So x's can't repeat. We don't want more than one x. I'm going to cross out my y's on this, and I want to see, do any of my x's repeat? I have -1. I have 1, 2. Oops, I'm writing -1 and 1 again. So this is not a function. Y is not a function of x. Over here, I'm going to cross out my y's. None of those numbers repeat, so y is a function of x. Now, on this mapping, what you have here are your x's and your y's. And I want each of these lines represents an ordered pair. So right now, my first ordered pair, this line right here, tells me that I have -1 and -6. So I only write that -1 down once. But because this right here has 2 lines, it means 2 -6 is a ordered pair and 2 -3. Well, guess what's happening here? My x's are repeating. So because my x's are repeating, this is not a function. Anytime you see 2 lines come from the x, it's not a function. Now let's talk about our graphing. Our graphing, we're going to use something called the vertical line test. And I want to draw a vertical line, and I want to count how many times that vertical line touches the function line. Now, I'm only looking at the yellow line. We do not care about these axis lines. Those don't matter. We only care about how many times the green line touches the yellow line. If I'm counting how many times that touches the line, Well, it touches it once there, and it touches it once there. So right now it is not a function because it touches more than once. I'm going to erase this line, and I want to try again. What if I draw it right there? Well, it touches once there and once there. It's not a function. Now I'm going to do the same thing on this one right here. How many times does it cross this line? Well, it's only going to cross it one time right here. So far it's a function, but we're going to repeat this a couple of times to make sure that it's still a function. How many times does it cross the line? Well, it only crosses one time there, so it's a function. This one right here is going to be a function because it only crosses one time. Okay. Now to go back to this one, I think I messed up when I was, this one was supposed to be the correct answer, but I think I messed up with the graph. So you may see an updated word problem here when you are looking at your paper. If you have any questions, please reach out to us. We're here for you guys.